In the following section, we are trying to solve exponential equations. The first kind of equations that we are attempting to solve are those ones that I can rewrite so that both sides of the equation will have the same base. If this happens, then it is going to be obvious that if the bases are the same on the left and the right side, that the exponents have to be equal to each other in order for the sides to be the same value. Here's a very silly quick example that illustrates this. 2 raised to the x is equal to 2 raised to the third. Well, it should be fairly simple to see that the only way that the left side is equal to the right side is if this exponent is indeed equal to 3. And this is how we are going to attempt all of the following examples. The first thing that we are going to do, we are going to rewrite the equation in such a way that on the left side and on the right side I will end up with the same base. Now, in the second step, I'm just going to be setting my exponents equal to each other. And in the third step, I'm going to be solving the resulting equation. Let's go ahead and do one. We want to solve 5 raised to the 3x minus 6 is equal to 125. Now, what I have to be able to is I'm going to have to be able to look at the number 5 and the number 125, and I have to identify both numbers in such a way that they are powers of the same base. 125 is nothing else but 5 raised to the third power. This is a perfect cube. So what I can do right now in my first step, I am going to rewrite my equation. 5 raised to the 3x minus 6 is supposed to be equal to 5 raised to the third. And in my second step now, I see that I have an exponent on the left side and I have an exponent on the right side, and the bases are the same. What this means is that the exponents have to be equal to each other, so I'm just setting them equal. Step 3, this is now a linear equation that we can solve. Adding 6 to both sides, we are getting 3x is equal to 9. Dividing both sides by 3, x had to be equal to 3. Now, here's a very good thing that you should always do. You can check your answers. So if x is equal to 3 and I plug this back in, then I'm going to get 5 raised to the 3 times 3. And I'm wondering if this is now really the same thing as 125. 125. So what do we have in the exponent? 3 times 3 is 9 minus 6, which is 5 raised to the 3, which is indeed 125 is equal to 125, which is a true statement. Which means that we have found our solution, and the solution was 3. Let's do another one. Here's one that is a slight little bit trickier than the one before, because in this case I look at my bases 8 and 4, and it is not as obvious as before. Well, I want to say quite. 8 is the same thing as 2 raised to the third. Raise all of this to the x plus 2 power. The number 4 is the same thing as 2 raised to the second. Raise all of this to the x minus 3. Do you notice that I have placed parentheses around my exponents? This is a precaution that I do not mess up in my next step. So what happens now here is the following. I have one exponent and I have a second exponent, and the rule tells me in order to simplify this that I am supposed to multiply my exponents. These are just the rules for exponents. And as I mentioned before, the rules will never change. Now I have accomplished, this is the end of step 1. On the left side I have a base of 2, on the right side I have a base of 2, and that means now that my exponents have to be equal to each other. I set my exponents equal to each other. 3 times x plus 2 is supposed to be equal to 2 times x minus 3. We are solving a linear equation in one variable. Substitution on the left side, substitution on the right side. Subtract. Now be careful with the signs. Let's rather write it underneath here. We subtract 6, and that means we get a negative 12 on the right side. A lot of times what happens is that students think that the 6's are going away. Now, the next step, we are just going to subtract 2x from both sides, and we are seeing that x is supposed to be equal to negative 12. Can I check this answer? Yes, you can. Let's check. 8 raised to the negative 12 plus 2. Is this really the same as 4 raised to the negative 12 minus 3? So on the left side we end up with 8 raised to the negative 10. And I'm wondering if this is the same thing as 4 raised to the negative 15. Now, I can do a similar trick than before. 8 was the same thing as 2 cubed, because I really do not want to take out my calculator right here. 4 is the same thing as 2 squared. And now I'm doing the same thing as before. I use the properties of exponents. 3 times a negative 10 is a negative 30. And this is in fact the same thing as 2 raised to the 2 times negative 15 is negative 30 as well. It is always a great idea to check your answers.